moving on, we're going to do solving systems using matrices, and we're going to go ahead and move up to a 3-equation system. So again, the very first step for using matrices when we're solving these guys is to put it into a matrix. Okay, so let me give you some direction here. Let's say we want to get rid of that 1. We can get rid of that, again, using our row operations. We can do row 3 minus row 1. I write that beside row 3 because that's the one we're replacing. So if I do that, top row doesn't change, second row doesn't change. It's the third row that's changing. So 1 minus 1 is 0, 3 minus a negative 1 is 4, and 2 minus 5 is negative 3, 5 minus 6 is negative 1. Oh, excuse me. 5 minus a negative 6 is negative 11. Sorry. Okay, then I want to get rid of this 3. I can get rid of that guy by doing row 2 minus 3 times row 1. Okay, if we do that, going down this next line, top row stays the same. Second row is the one we're changing, so 3 minus 3 is 0. 3 minus a negative 3 is 6. 1 minus 15 is negative 16. Negative 1 minus 15 is negative 16. And then we have 10 plus 18 minus a negative 18 plus 18 is 28. And the last row stays the same. Now, at this point, I want to get rid of this 4. So I'm going to compare it to the 6 above it. We don't need to go all the way up to that top row because we'd be adding this 1. Let me mark this. We'd be adding this 1 back in on top of a 0. So we can't do that. So we need to do this 6 with this 4. So if I do that, I can do, let's see, the least common multiple of 6 and 4 is 12. So let's say I do 3 times row 3 minus 2 times row 2. That would eliminate that guy. So top row stays the same, second row stays the same. So the last row is changing. So we get 0. 12 minus 12 is 0. Negative 9 plus 32 is going to be 23. And then looks like we got 33 minus 56, which is negative 23. Now that last row is almost in the correct form. Again, to go to row reduced echelon form of these guys, we want to shoot for this. I talked about that in the last video. Okay, so the last row is almost there. All we got to do is divide by 23, or multiply by 1 over 23. So top row stays the same, second row stays the same. It's the last row that's changing. So we get 0, 0, 1, and negative 1. Now, looking at my row reduced echelon form, I need to get a 0 right there. I have 16, so I need to eliminate that guy. I'm going to use row 3 to do that. So I can do row 2 plus 16 times row 3. Top row I'm not doing anything with. Second row I'm changing. So 0 plus 0 is 0. 6 plus 0 is 6. Negative 16 plus 16 is 0. 28 plus a negative 16 is 12. And the last row stays the same. So then all I have to do now to get the second row in row reduced echelon form is to divide by 6. Top row stays the same. Second row is dividing by 6. Okay, almost there. Now, looking at the top row, I need zeros in these positions. So I need to eliminate those. So I'm going to use the row 2 and row 3 to eliminate those. So right away you can see that I can do row 1 plus row 2 to get rid of that negative 1 in the second position. So that's going to be 1, 0, 5 plus 0 is still 5, negative 6 plus 2 is negative 4. Second row stays the same. Last row stays the same. Then I can do row 1 minus 5 times row 3 to get rid of that 5. So 1 plus 0 is 1, 0 plus 0 is 0, 5 minus 5 is 0. Negative 4 plus 5 is 1, and the other rows all stay the same. And so the solution is x equal to 1, y equal to 2, and z equal to negative 1. Now, the great thing about doing these row operations with matrices is I can do multiple steps at once and eliminate multiple things at once. So on this example, I'm going to do that. Now, it's not necessary because it can be confusing and you could get lost while you're doing it. But that's the whole point of matrices, is to pull out the most pertinent information and solve it in a more efficient way. So that's the whole point, is being more efficient. So let's try to be more efficient in solving this guy. Okay, so new example, if we put this into a matrix, we get 1, 6, 3, 4, 2, 1, 2, 3, 3, negative 2, 1, 0. Okay, the exact same process before. I'm going to get rid of that 3. So if I do row 3 minus 3 times row 1, that'll get rid of it. But if you see, I need to get rid of that 2 in row 2, so I can also do row 2 minus 2 times row 1. That makes it pretty easy on me. Or, not really makes it easy, but just skips a step. So here we go. Let's do row 2. So 2 minus 2 is 0. 1 minus 12 is negative 11. 2 minus 6 is negative 4. 3 minus 8 is negative 5. Last row, 3 minus 3 is 0. Negative 2 minus 18 is negative 20. 1 minus 9 is negative 8. And 0 minus 12 is negative 12. Now right here, at this point, I can divide everything in row 3 by negative 4, and it just takes it to a little bit simpler form. So let's do that so that we don't make stuff too big of numbers and make it too complicated for ourselves. So this becomes 0, 5, 2, 3. Okay? So then now I'm going to eliminate this 5. I cannot combine steps on this step just yet. So let's just do the least common multiple of 5 and negative 11 is negative 55. So let's do 11 times row 3 plus 5 times row 2. Top row stays the same. Second row stays the same. Third row is the one that's changing. So we get 0. And then 55 plus negative 55 is 0. 22 plus negative 20 is 2. 33 plus negative 55, or excuse me, 33 plus negative 25 is 8. What happened? Sorry. Is 8. Okay, so then if we divide everything in row 3 by 2, we will get it to the proper form of row reduced echelon form. So we get this. Oops. Okay, so then now I can go back to doing multiple steps, because I can use that 1 on the bottom row to eliminate the 4 and the 3. So on that top row, I can do row 1 minus 3 times row 3. On row 2, I can do row 2 plus 4 times row 3. When I do that, top row stays top row does not stay the same. My bad. I have 1 minus 0 is 1, 6 minus 0 is 6, 3 minus 3 is 0, and then we have 4 minus a negative 12 is negative 8. Sorry, I was just trying to make sure I was making the right step. Second row, 0 minus 0 is 0. Negative 11 minus 0 is negative 11. Negative 4 minus 4 is 0. And then negative 5 plus 16 should be 11. Last row stays the same. Then I can divide by negative 11 on row 2 to get it to the proper form. And then the very last step is to get the top row to the proper form, so I can do row 1 minus 6 times row 2. So that's 1 minus 0 is 1. 6 minus 6 is 0. 0 minus 0 is 0. And then negative 8 plus 6 is negative 2. And then the other rows are the same. So the correct answer is x equal to negative 2, y equal to negative 1, and z equal to 4. Now I want to show one more thing before we end this video. Let's take another system. Okay, now we talked about dependent and inconsistent systems whenever I solve them with systems, and it really shows up the same way with matrices. So I just want to show, what happens. Show what happens whenever you see it in a matrix instead of a system. Okay, so right here, if I were to try to eliminate that negative 3 on the last row, I could do row 3 plus 3 times row 2. If I do that, top row stays the same. Second row, I'm not doing anything with it. But the last row, I get negative 3 plus 3, which is 0. 6 plus negative 6 is 0. 6 plus negative 6 is 0. Negative 24 plus 24 is 0. So that whole last row, I end up with 0 equals 0. If we think about what that row says, 0x plus 0y plus 0z equals 0, or 0 equals 0, which is true, but it doesn't really tell us anything. But that tells us that these two equations up here are the exact same equation. Okay, so when we learned about dependent and inconsistent systems, we know that if two of them are the same, we say it's dependent system, and there's infinitely many solutions. Inconsistent is when we end up with some situation like 0 equals some number. Okay, if you ever end up with 0 equals some number, that's inconsistent, and that's no solution. And so in a matrix, the way that would show up is we'd go to try to solve it, and we'd end up with, say, like 2, 3, 8, and 0, 0, 4. So that bottom equation says 0x plus 0y equals 4, or 0 equals 4, which is untrue. So we would say this one is inconsistent or no solution. Okay? So we'll stop there.